Hey math kids, today we're going to continue talking about quadratic functions. This time we're talking about the graphs of quadratic functions. And just a few things. So if we have ax squared plus bx plus c equals y, if a is greater than 0, we're going to get a parabola that looks like this. So if we have a positive value out in front of x squared, and then if we have a negative value, it's going to go upside down. Okay, and obviously a cannot equal 0, because if that happened, it wouldn't be quadratic anymore, because this piece would go away, and then it would just be a line. It would be a linear function. Yeah. So let's move on to some examples. So we have y equals 2 times x plus 3, x minus 1. And sketch the graph using axis intercepts and state the equation of the axis of symmetry. So just wants us to graph this, but in a rough sense. So what we're going to do, we're going to pull out the axis intercepts, the x, but just by changing these signs. So we're going to have x equal to negative 3 and positive 1. Because this is a positive 3 and a negative 1, we change the signs. And so we know we're going to cross right here, and we know we're going to cross right here. So we just mark dots where we cross, and knowing the middle of this, the vertex or the axis of symmetry is going to happen right in the middle of those two dots. And so if we go 1, 2, 3, 4, the width right here is 4, and so halfway between that is going to show us where the middle is, and so it's right here. And it wants us to mark that as x equals negative 1. And so in a and we need to find the y-intercept. So to find the y-intercept, we're going to plug in 0 for the x's. And that is 2 times 3 times negative 1. So that's 6, and then we get negative 6. So 1, 2, 3, 4, 5, 6. That's our y-intercept. And then we can connect the dots. It's kind of a bad parabola. But we don't know where the vertex is with this method, other than we know that it's at x equals negative 1. But we know the x and y intercepts for that. Okay, we're going to try another one like that. So y equals negative 2 times quantity x minus 1 and times x minus 2. So the first thing, pull out the x-intercepts. So it's going to be 1 and 2. And so we go 1, 2. Now the axis of symmetry is going to be in between that. So it's going to be x is equal to 3/2 or 1.5. And then we need to find the y-intercept. So we plug in 0 for the x's into the green equation. So that's negative 2 times negative 1 times negative 2. And so that's going to be negative and 4. Like that. And so if we connect the dots, let's see. Having a hard time with that. Like that, and then go through there. Continue there. Alright. Since this leading piece right here is negative, we know it should be upside down, and so it fits everything that we expect. And let's do it one more time. Y equals 1/2. X plus 2, quantity squared. So what this is going to do is we're going to pull out x equals negative 2 and technically another negative 2, but we know that it's just going to kiss at that point. So -2, and since this is positive, it's going to come down and just kiss right there. So we still need to find our y-intercept, so we plug in 1/2 times 0 plus 2 quantity squared. So that's 1/2 times 2 squared, 1/2 times 4, which is equal to 2. And we just connect that, and then it wants our axis of symmetry, which is just going to be right there at x equals -2. Alright, moving on to the next example. It says use the vertex axis of symmetry and y-intercept to graph. So we do y equals -2, x plus 1 squared plus 4. This is in what's called vertex form, which is y equals a x minus h plus k, and then squared right there. So when we're doing this one, we want to pull out the vertex, and so this one we change the sign, but this one we keep the sign. So this is a +1, it becomes a negative. This is a +4, stays positive. Okay, so when we're graphing, we can graph this -1, 1, 2, 3, 4. So we know that's the vertex. This is negative, so we know it's going to be downward facing, upside down U. But we need the axis of symmetry as well. So we know that's going to be like that. And it just wants the y-intercept, I guess. So we plug in a 0 for x again. So -2, 0 plus 1, quantity squared, plus 4. 0 plus 1 is 1, 1 squared is 1, 1 times -2 is -2 plus 4. Add those together, we get 2. So we know we're going to cross the y-axis right here. Now, since we're 1 away from the y-axis, we would also go 1 away from the vertex, and then we can connect the dots. And that's everything on that one. Okay, next one, we're going to write y equals x squared plus 4x plus 3 in vertex form. Let's see, and then they want us to sketch it after we do that. So what we need to do is complete the square first. So we're going to set y equal to 0. If you forgot how to complete the square, watch the complete the square video, because I'm going to go through this pretty fast. So we subtract 3, we get -3 equals x squared plus 4x. We would divide by a number out in front right here, but there isn't one, so we move on to the L step, where we divide by 2, and then we square. We add that to both sides. We do that, and so that's 1. And we do the magic step, which is taking all of this. We say x plus the elbow squared. Now we need to move this back onto this side. So 0 equals x plus 2 squared minus 1. And then we just change that 0 back to a y. Now, if there's a number out in front of here, we'd have to do an additional step, but I'm not going to worry about that yet. Okay, now we need to graph this. So we find the vertex. Once again, we change the sign here, so it's -2, and we keep the sign there. So it's -2, -1. And we need to find the y-intercept as well. So we plug in 0. So y equals 0 plus 2 squared minus 1. 2 squared, so 0 plus 2 is 2. 2 squared is 4. 4 minus 1 is 3. So we're going to cross at 3. Once again, we are 2 away from the axis, so we'll go 2 in this direction. And because of the symmetry, I have the hardest time connecting dots, but there we go. And that would be the graph. Okay, gotta get some more room. Alright, so we're going to do y equals 3x squared minus 4x plus 1. And we need to put it in vertex form. And let's see. Write down the coordinates of the vertex and sketch the quadratic. Yeah. So, once again, complete the square. So this is 0. And so we're just going to subtract 1 onto both sides. Subtract 1 equals 3x squared minus 4x. Divide everything by the leading coefficient. So in this case, 3. Then we do the L step, which is divide by 2. So that's going to be 2/3. Then we square the top, square the bottom. So 4/9. That's what we add to both sides. Okay. So to add this, we'll do 3 and 3 on top. So we're doing 4/9 minus 3/9. So that's going to be 1/9. Over here, we're looking at this piece, and we're going to do the magic step. So that's going to be x plus the elbow. Oh, whoops, this was minus though, so that should be negative when we did the first piece. So this was minus, and so negative 2/3 quantity squared. All right, and then we subtract 1/9, subtract 1/9. And we get x minus 2/3 quantity squared minus 1/9. And then you have to go all the way back up to the original, and whatever the original a term is, so in this case 3, we have to multiply both pieces by 3. So we're going to do a 3 here and a 3 here. So we get 3 quantity x minus 2/3 squared. And then the 3 on top cancels one of these, so it's negative 1/3, and that's equal to y. So that's the first piece, and then we need to use that to graph. So if we have a graph right here, we pull out our vertex. It's going to be 2/3 comma negative 1/3. So if I'm calling that 1, 2/3 will be about right there, negative 1/3. Okay, we have a right side up parabola. And we just need to find the y-intercept. So we do 3 times 0 minus 2/3, quantity squared minus 1/3. And so we 0 minus 2/3 is just negative 2/3. Square the top, square the bottom. So we're going to get 4/9. We multiply this, which actually just cancels that. So we have 4/3 minus 1/3. So that is 3/3. Which is just 1. And so this is going to cross at 1. And go there, go there. And that's going to be our final answer on that one. And we just have one more problem. And this one